So here are all the non-incline and non-friction forces problems. So we're going to begin with the first one. It says a 4-kilogram bucket is drawn out of a well with a rope. The tension in the rope is 50 newtons while you do this. A. What is the acceleration of the bucket? B. How long does it take to haul it 20 meters if it started at rest? So when you're approaching these kind of problems, first of all, you want to make a free body diagram. So I'm going to draw one here. Here's our object. And we know that there is a tension force pulling it upwards. And then if we think about it, there's only one other force acting against it, and that's going to be gravity. Alright, so how do we approach this? Well, we're going to use Newton's second law. Remember, the net force, keyword net, is equal to mass of the system times acceleration of the system. And acceleration of the system is what we're looking for. And we already know mass. So how do we know what the net force is? Well, this bucket is moving upwards, right? So if we look at our free body diagram, there are two forces that are acting against each other. So we can write that the net force is equal to the tension minus the gravity. And why is it this way and not the other way around? Well, the object is moving upwards, so that's implying that the tension force is stronger than the gravitational force. Because if the gravitational force was stronger, then it will be this minus the tension force, and the object would be being pulled downwards. So yeah, you just have to look at how the object is moving in this case and just use your intuition. Anyways, now if we set these two equal to each other, we end up having everything except for acceleration. So let's just plug that in. So we have 50 newtons minus gravity, which is 4 kilograms times 9.8 meters per second squared equals 4 kilograms times acceleration. And you're going to notice here that I did not put negative 9.8 meters per second squared because we've already established up here with this minus sign that the gravitational force is in the opposite direction of the tension force. And once you solve all of this out, you get that A is equal to 2.7 meters per second squared. And there you have the solution for part A. And in part B, how long does it take to haul it 20 meters if it started at rest? And this is a kinematics problem. So now that you have acceleration, you just need to figure out two other factors. So it gives you that you have to haul it 20 meters, so x equals 20 meters. And then you're looking for time, question mark. And you can assume that it starts from rest. And we have an entire video why you can say it doesn't end at rest, which is in the final velocity video. But going back to this problem, at the bottom of the well, it just starts from rest, 0 meters per second. And then we're going to use this equation. And then just plug everything in. And then solve for t, and for t you get 3.85 seconds. There you go. We solved physics.